Okay, so this is an example of raw data that has been collected when I did the beans, and you can quickly see that I've put them in groups of 5. That's the way you do tallies, so 5, 10, 15, 20, 25, 30, 35, 40, 43. And if you did it this way, and that is the tendency of some students, just keep on putting ticks, well then you have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hang on, was I here or here? But this is the point, is that you don't want to just put them on line like that. When you have raw data, you group it in 5s, so you can count them in 5s. 5 times tables is supposed to be easier than most, but we'll assume that you can count in 5s. 5, 10, 15, 20, 25, 30, 35, 40, 41, 2, 3. 43 is the total. And then we organize the data. I did it for black, red and gold, so that's the variable. I mean, that's normally the X value, the variable, and we put that on top of the table. So we have it organized into a table, the variable on top, in other words what we're looking at, the color, and in this time then the frequency, and we put in F for that. The frequency is 43, 37 and gold 34. Okay, so the next part of this is to start interpreting the data, to make sense of it and see what use it has. So what I'll do is I am going to total up. I'm going to sum up. Now some of you have seen this symbol. This is the symbol to sigma, which means to sum or add up all these frequencies. So sigma f. I want to add up all the f values. So to do that, it's straightforward enough. The add up 43, 37 and 34. So I just quickly do that. I don't like guessing it. 43 plus 37 plus 34 equals 114. So there's 114 different color beans. 114. Okay, so 43 out of 114 are black, and the question is, what percentage is that? So the sum up is 114. So turning each into a percentage, so 43 out of, or divided by 114, and then to turn it into a percentage, all I simply do is the fraction multiplied by 100. Now I could simplify this. In this case I couldn't, but it's possible to simplify these fractions. You don't need to. You can just use a calculator to do this. So it's 43 divided by 114 multiplied by 100. And just make sure you can see that. 43 divided by 114 multiplied by 100 equals, equals 37.7192985%. So I'm going to round that off to 37.7%. I'm going to round off this to the second digit. So it's 37.7% equals 37.7%. 37.7% of the beans were black. So I'll just shift this up a little bit. The next one we have is 37 out of 114 beans were red. Multiply that by 100 equals, so again, calculator, clear, 37 divided by 114 multiplied by 100 equals 32.456. So I'm going to round this off to 32.5. Now just so you know, you remember your rounding, the 5 is strong enough to change the 4 up 1. So it's closer to 50 than it is to 40. So if you always assume that the 5 is the second decimal point is strong enough, it's 5 or more, is strong enough to change the first decimal point to a 5. So as you think of it as in percent, is 32.50 as opposed to 32.40. So that's 32.5%. And the last one then is 34 out of 114. Multiply that by 100 to turn it into a percent, because that's, remember, that's a fraction of a percent of 100. So 34 divided by 114 multiplied by 100 equals 29.8, and to round it off to one decimal place, 29.8. The 2 is not strong enough to change the 8, so just leave it at 29.8%. 29.8%. So that's interpreting the information and by turning it into a percentage. I can say that 37.7% of the beans were black, 32.5% of the beans were red, and 29.8% of the beans were gold. So that's just a way of interpreting information. It's fairly close. They're about shy of 1/3 each, roughly. But it's a nice distribution, kind of fairly even. The range is between 37.7% and 29.8%, the highest to the lowest. Okay, that's that.